Hello, ladies and gentlemen. This is part 4 of our multi-part series on an introduction to atoms and atomic structure. The first 3-part videos of this multi-part series took a look at the history of atoms, how they were discovered, how different aspects of atoms were discovered, and then in part 3, we also took a look at the different parts of an atom, the major parts. Protons, which are positively charged, neutrons, which are neutrally charged, and electrons, which are negatively charged. Today in part 4, we are going to start to take a look at something called the atomic number. During parts 4 and 5, we will be finding out how to find the atomic mass, the atomic number, which we'll do today, as well as symbols of elements from the periodic table. We'll be able to calculate how many neutrons are in a particular atom, and we'll be able to explain what an isotope is. So the atomic number tells us the number of protons in an element. That is critical. Number of protons in an element is a really important piece of information for us to know. You can find the atomic number on the periodic table. It is actually a whole number. It's usually very prominently displayed in each square of the periodic table. It's perhaps in many ways the most important number to be found in each square of the periodic table. I wish that I could tell you that every periodic table is set up the exact same way, and so I wish I could say like every periodic table puts the atomic number at the top center of each square, but unfortunately that is not true. There is not a standardized way of doing that. So some periodic tables are going to have the atomic number in the top center. Some might have it top left-hand corner or top right-hand corner. Others might have it down in the bottom center. If you were to come to class and take a look at my periodic table on the wall, you would find that it is not in any of those places. It is near the bottom, but not at the bottom of each square. It's over on the left-hand side, but each of the atomic numbers is colored red to make it very prominent and obvious. Like I said, it tells us the number of protons in an element. So for example, oxygen's atomic number is 8. If you look at the periodic table, that tells us that there are 8 protons in oxygen's nucleus. And we know that protons are found in the nucleus of an atom. We learned that in part 3 of this series. So if you looked at a periodic table, you would see that the atomic number for iron is 26. So that tells us there are 26 protons in every nucleus of iron. We could also look and see that the atomic number for sodium is 11. So we know that sodium has 11 protons in its nucleus. No matter which sodium atom we're talking about, doesn't matter. It's always going to have 11 protons. So we have almost exclusively to this point been talking about what we call neutral elements or neutral atoms. They have no charge. And when we're talking about a neutral element, we're talking about an atom that has the exact same number of protons as it does electrons. That means it has the exact same number of positive particles as it does negative particles. So every positive is offset by a negative, which makes it neutral. Okay, for now, that's really the only kind of element that we're going or element or atom that we're going to talk about. Once we get to part 6 of this series, we'll start to talk about charged particles, where you might have a positive particle or a negative, or excuse me, a positive atom or a negative atom. But for now, we're talking about neutral elements that do not have a charge. So the protons always are going to be equal to the electrons in those. Just so you know, the number of protons of an element is never going to change, or at least if it does, it's no longer that element. For instance, if you looked at a periodic table, you would see that zinc has an atomic number of 30. This means that zinc has 30 protons. Always. Always. Every zinc atom in the entire universe has 30 protons, because that's what makes it a zinc atom. That's its identity. All right. If for some strange reason zinc were to lose a proton, so now there were 29 protons, it would no longer be zinc. It would now be copper, because copper has an atomic number of 29, which means it has 29 protons. So an element always has the same number of protons. It's almost like our social security number. If you're an American citizen, you have a social security number, and that is your identity as far as the government is concerned. That identifies who you are. For atoms, the number of protons identifies who it is or what it is. All right, every silver atom has 47 protons because its atomic number is 47. All right, so ladies and gentlemen, in our next video in this series, we're going to start to take a look at some other numbers that can either be found on the periodic table or calculated based on information given to us or information found on the periodic table. Things like atomic mass and mass number, and we're also going to talk a little bit about something called an isotope. Thank you, ladies and gents, and we'll see you later.